Alright, this problem is an example of trying to find the length and the width of a rectangle. When you're working with a rectangle, it's important to work with a picture. So we now have a picture of a rectangle. Let's see if we can't identify some information from the words in this problem. The length of a rectangle is 6 meters less than the width. So the length is less than the width. So to label this correctly, the width would be the longer one in this case, and the length would be the shorter one in this case. But specifically, the length is 6 meters less than the width. Now, I don't usually use L and W for too long in a problem, unless I think that it's appropriate. In this case, I'm going to go to X. So I don't know which one's which. I'm going to let the W equal X. Now this is a general pattern that you can use when you have a problem. In this case it says the length is, so it's talking about the length. So they're giving you an equation, because the is an equals. They're giving you an equation for L. Great. They don't tell you anything about the width. They don't say the width is anything. So you really don't know about the width at all. You know more about the length because they're going to give you an equation. But you don't know about the width. So whichever one in here they don't talk about much. They don't have an is statement. Like for the width, that's the one I usually let at equal X. Now the length is equals L equals 6 meters less than the width. So you take the width and you subtract 6. Alright, so we now have the length and the width in terms of a variable x. Next up, it says the area is 72. Often the area is written inside. In this case, it was 72 square meters. Now that we have our picture drawn, we have to look for what kind of relationships are there between length, width, and area. And we end up with the area formula, A equals LW. So if I plug in A, L, and W into this equation, I will get 72 equals parenthesis. Now because L is a binomial, it's going to be multiplied by width. It needs parentheses around it. You almost always put a binomial in parentheses when you work with it. So parenthesis x minus 6, close parenthesis, and the width is x. Okay, great. We are looking at an equation that now just has x in it. What we're going to do is try to solve this equation. We will start off by doing simple steps. For example, distributing through parentheses. 72 equals x squared minus 6x. Now this is an x squared polynomial equation, a quadratic equation. Commonly what you'll want to do is get everything on one side. So I'm going to subtract the 72, and I'll move up here. We now have 0 equals x squared minus 6x minus 72. Okay, this equation is going to be something we're going to try to factor. We're going to try to factor this so that we can solve for x. Now the factoring technique we use, I can put a 1 in front of the x squared. We take the 1 times the 72, and that gives us 72. And we look for factors of 72 that add up to negative 6. I forgot the negative sign. Negative, negative. So negative 72. Let me see if I can fix that a little bit. Put a negative better in front of there. There we go. Nope, nope. Come on. My tablet is working. Negative 72. So 6, let's see, what are the factors of 72? Let's come up like 9 and 8. 6 and 12. One of these already works. So we're looking for ones 6 and 12 that add up to negative 6. So that would be minus 12 and plus 6. That'll be negative 6. So that gives us now 0 equals x squared. What we do with the negative 6x is break it up into plus 6x and minus 12x. It doesn't matter what order in general. So I will just do it in the order I came up with it. Okay. Now I'm going to factor by grouping. Out of the first, I'll pull out an x, leaving x plus 6. Now our second term has a negative in front of it. Anytime you have a negative in the first piece you're trying to factor, you want to factor out that negative. So I'm going to factor out negative 12, leaving me x plus 6. You can verify this. If you distribute this through, you have negative 12x and negative 72. Perfect. If you had a minus sign here, it wouldn't work out. So make sure you have a plus when you factor. When you factor out a negative, it changes negatives to positives. Okay, we can factor out further, factoring out the x plus 6 that's now in common, leaving us an x minus 12. All right, let's make a little more space. We have a property that if we have two unknown numbers multiplied together equals 0, one of these has to be 0. So either the x plus 6 equals 0 or the x minus 12 equals 0. This first one we can solve, subtracting 6 to get us x equals negative 6. The second one we can solve by adding 12 to get us x equals 12. Potentially two answers. Let's take a look at this situation. We have a rectangle, x minus 6, 72. Because x represents a distance, a length of this rectangle, it's impossible to have a negative. Negative distances don't make sense. So we get to throw out the x equals negative 6, leaving us just x equals 12. Now we take this value and we plug it into the x's in our picture. And we get this picture. 12, 72, and when I plug in 12 into x minus 6, 12 minus 6 is 6. Alright, so we have the width is 12 meters, and the length is 6 meters. That completes this problem. If you have any questions on why each of those are the way they are, again, you go back to the initial part, and we had started with width equals x, and length is x minus 6. So the width was x, so this is the width, and that's why I knew that the width was the 12 meters and the length is 6 meters. Okay.